Good evening, distinguished engineers. I think we are going to start now. Sorry, we are starting 30 minutes behind schedule. I was trying to set up so that we can start in earnest. My name is Engineer Ben O.C. Oko. I'm going to be the resource person for today's lecture. Today's lecture is a one-day lecture on the use of Civilsoft Quickcivilseries Quickstructure 9.0 for structural design and detailing. For some of us who are very conversant with Civilsoft, Civilsoft is an indigenous software which was developed in Nigeria by a Nigerian. It is purely 100% indigenous software, and it thinks like a Nigerian, speaks like a Nigerian, and works like a Nigerian. Why I'm saying this is that most softwares that are not indigenous softwares that we use, there are some parameters. Once you want to make some adjustments in their parameters, you discover that they may not give you that leverage for you to make the kind of adjustment you want to make. For instance, we know that practically what we have in the market, or for instance, if you want to reduce, most times we use 4110 as our characteristic strength of steel for our design. And the 4110 by BS 8110 standard, I'm not even talking about the Euro code now, anything below 460 is my steel. So if you are using those foreign softwares, if you want to make some adjustment and reduce your steel strength to 410, it will be reading it or capturing it as mild steel. But the Civilsoft gives you the flexibility to be able to, make any adjustment you want to make. That's why I said it thinks like a Nigerian, and everything about it was Nigeria was put into consideration, what is prevalent in our environment. And I must give the developer Henry Oji kudos for a very great job. He over the years, the software has gone through series of updates and upgrade. And today we have, initially when it came on board, it was like an Excel sheet, just like the RCC spreadsheet we have in the United Kingdom. And from the spreadsheet, it metamorphosed to a single analysis software that can be used only for analysis. When you finish your analysis, you will go and do your detailing yourself, and from that, it was in the modeling part of it was integrated into it, not really as a single unit, but you can finish your analysis, transfer your outputs to the detailing part of the software, and detail according to it will detail according to the information given to the software. And then that was the last stage before the two were integrated together. Now you can actually use the software to do your analysis, your design, and then automatically every output you get from your analysis, the software will capture it in the detailing tool and then give you your output. Fantastic. One incredible thing about the software is its ability to detail. And honestly speaking, not because I am giving the lecture, most of the softwares I know, I don't think there is any structural software that details like Civilsoft. And I want to state here categorically, there is no, all softwares are fantastic. There is no, I can't, arrogate to any particular software the dignity of the chair, or this software is the best. It depends on what you are doing. Me personally, I have used CivilSoft for many years, and it has always given me the result that I want. Most times, depending on the complexity of the work we are doing, sometimes we discover that you may end up not using one particular software for one particular job. You may need 2 or 3 extra softwares, as I say, depending on the kind of job you are handling. So all the softwares, there is no particular software that can give you all the things you need at any particular time. It's just the choice is yours for you to make use of the one that can provide solution to your problem at any particular time. Before we commence the lecture, I always like to give, a very little background to the use of applications for design. And for over some years now, I have been giving lecture during the Nigerian Site of Engineers workshop for intending corporate members. And I have been teaching design fundamentals. And I always use of computer-aided applications. The word aided simply means to assist. To aid is to assist. And we were taught in school that computer is just garbage in and garbage out. Whatever information you give computer is the information the computer is going to use to do your calculation. So I dare say, and I say it emphatically without any fear of contradiction, that your knowledge of any software does not confer on you an authority in that discipline or in that field. That you know how to use CivilSoft or you know how to use any particular software does not make you a good structural engineer. If you want to be a good structural engineer, you must learn it from the basics. You must know the fundamentals. If you give computer a wrong information or any software a wrong information, the software is going to give you a wrong output. So if you don't know it from the first principle, I bet you when the software gives you the wrong answer, you may not know. But if I'm doing a design and if I have a beam of 5 meters and just for a residential apartment and I'm having an output of maybe AS provided of maybe 8Y25, something is wrong. But if I don't know, if I didn't know it from first principle, I will not know. Just by scanning through my output, I should be able to know that there is a problem. Maybe once I see that kind of output, I simply go and check. Maybe there was a place I made a wrong input and I can quickly adjust and redesign. But if I don't know it from the first principle, I may not. There's every tendency that I may not know even when I'm making a mistake. So I say that learning this application or learning other applications does not confer you an authority in structural engineering. You should go back to the basics from the first principle and study it and know it. The softwares or the applications are just here to assist you, to make your work easier, for you to get your result quicker and to make things very easy for you. I repeat, you have to know it and know it from the very first principle. So this is what we are going to, in the course of the lecture, we are going to be using real life experiences. It's going to be interactive. We are going to be using real life experiences to, show how you can apply your knowledge of, the engineering practice in the application of the software. Because the truth is this, if you have mastered the act, when you use any software, you can know how to navigate your way through the software. And even if the software was not designed, for instance, you want to design a building or a structure that has maybe a swimming pool on the 5th floor, there may not be any provision in that software to provide to analyze such situation, but you can. if you, from your experience of structures, you will be able to know, okay, what is the density of water, what is the, you can be able to navigate your way through. And that is why I keep emphasizing on the need that we should know it from the first principle. And if we know it from the first principle, I bet you every other thing shall be added onto you. So we go straight to the software. I will share my screen now. Let me quickly get the software so that we can commence. It's not going to, some people have been calling and been asking, will one day be really enough for us to do this? And I bet you have done this for many years, and I can categorically tell you that one day is enough. Is enough for us to finish whatever we want to do. Every other thing will just be an additional work if you have the software. If you don't have it after the lecture, you can always get it. I don't know if you can see my screen. Can you see my screen?
Yes, you can see your screen.
Yes, we can see your screen.
Fantastic. So that makes it simple. So when you, this is the software. When you
it's a little blood though.
Oh, seriously?
Yeah, it's not very sharp.
Oh dear. Let me, I don't know why it is not. Let me just look at what I have. Let me watch it from my phone and see. But on my system, it is showing clearly.
Question for you, please.
Let me quickly. Yeah, somebody wants to ask the question.
Yeah. The software I have actually is the CivilSoft 8.0. So I don't know if that
you can use it. Is the same. Is the same.
Recording in progress.
Okay, I've seen what you have seen.
I would also want you to throw more light on the license, the license part of it.
No problem. Every question after the lecture shall be addressed. Okay, let me continue. I don't know why it is showing like that. But okay, but let me, maybe it's the resolution setting. I can always, I will look for a way to adjust it. So the first thing, when you open the software, the first thing you see is the icon that is there. That's the view that is showing. You simply go to the file and click on new project. And this comes out. It will, how the software is designed in a way that it is very interactive. For any action you want to take, the software will ask you a question, and they, be able to guide you on and give you information about that action you're about to take. Like, it has given us the overview, and it is telling us that we have to, before we proceed, we need to set the default, change the default settings. And everybody that uses any application, whether even the Microsoft Word we use, we normally do the default setting. If it's Microsoft Word, you can change the font size, you can change everything. And it is the same thing with every software. You change your default setting according to what you are designing. Now, let's take it one after the other. The first one is the imposed load. The first setting here for imposed load is 1.5. We have the codes. You can always change the imposed load based on what you are designing. The imposed load vary based on the usage of the structure. So I'm not just the structure. Let me clarify something, because sometimes, we just use one general imposed load. For instance, you have a residential apartment. Yes, if the imposed load for residential apartment is 1.5, there may be a residential apartment that a particular section of that residential apartment, for instance, may be a library or may even be a gym that may be on the first floor. You cannot use the same imposed load that you use for a living room, for a library, or for a gym. After you have created your panels, we'll see that in the course of this. After you have created your panel, you will go back to that particular panel where you have that. Please, can we mute our mics as we come in, please? You still go to that particular panel and you change Jibril Usman, please. You change the imposed load that applies to that particular place. I will show you in the course of this. Now, another place that is very important to me is the bearing capacity. Now, what we have as the default setting is 200. I tell you, it is very important, fundamentally important. If you are doing a design, always insist that your client engages a geotechnical engineer to do the soil test, and they give you a soil report that is signed by an engineer. Please don't assume. We always want to assume. We always want to give this man impression that there is always a way to navigate around it. Soil is a very, very sensitive part of a structure. You cannot, I have never seen anybody that went to a hospital for blood transfusion and the doctors say, let us assume that the blood group is A positive, or let us assume that it is this. They must conduct tests and they must use the one that matches. So we should always insist, we should stop all these unnecessary assumptions. Don't assume. Let us get it right. Insist that this is what it should be. There is no cutting corners in engineering. There is no shortcut in engineering. If it is A, it is A. If it is not A, there is nothing like is like A. So let's take that at the back of our mind. Another one is the strength of concrete. Most times, it's always good also to do feasibility studies before you commence your. Try to understand who is going to, if you are doing the design, find out who is going to carry out this construction. Most of the times we use the figures that we see on textbooks that in real life situation, they are not achievable. You see people designing with strength of concrete 35. And who is going to do that? Who is going to do that construction? Is it Julius Berger? Is it Dan Data? Is it which company? This you go to site, the people who are going to implement these are just, sometimes they are even not going to use mixers. It's manual mixing. So there's another topic for another day. Honestly speaking, always try to, when you want to do your design, play it back from the other. Just play the construction of that design. How is it going to be implemented? This thing you are designing, is it implementable? We know the situation in Nigeria. That is not where we are going. But the truth is this, that most of these things are not achievable in sight. So you have to use the one that is achievable. Now, another disaster, which many of us know, is the strength of steel. Market. I was in Singapore in 2013. I visited a company called Nasty. When we looked at their catalogs, the strength of steel, there was no steel that they were using in project, because we visited a company and they were using the Nasty. All these the steel reinforcement bars there was one of them that was less than 550. Strength of steel. But what is the situation in Nigeria? This 410 was proposed by Oyenuga in his book. Go and check. That book was first published around 2003. or 2002. That's almost about 20 years. That was what was prevalent then, maybe in the market, against 460. What the code says is 460. But at that time, maybe from the research or from the series of tests conducted, the average strength available in the market was around this 410, and that was why he recommended 410. My brother, if you go to market, buy steel and go and conduct tests, I will bet you that you may, if you get, many of us know what I'm talking, if you get 350, you are lucky. So we should always, we have organizations like NEBRE, we have many companies that do conduct tests. You can always reach out to your friends who work in these organizations. If you're in Abuja, you can walk to NEBRE, they do tests almost every day. Find out the average strength they get from the test, they conduct. That should be able to give you the idea of what you are, except you know it's not that you cannot get, there's a project going on in Abuja, FIRS building, and it's the same NEBRE that is testing their reinforcement. The minimum reinforcement they have is 500. That's what they are using. The strength is achievable. That's why I say it depends on who is carrying out the construction. So if it is a construction like that kind of project, you cannot joke with it. And that is why it is like that. But most of the projects, your uncle wants to construct a building and he wants to buy his reinforcement, definitely he will want to go to day and buy. And when you tell him this reinforcement, you are going to subject it to test, he will say, look at this man, he wants me to waste more. That is the impression they always have. That is you cannot, I'm telling you, you cannot get that strength. You cannot. Even Eurocode now is recommending 500. So these are some of the fundamental things. That's why it is important to do feasibility studies, for you to have an idea of, what is actually prevalent in the market, so that you don't just design what will be fantastic on paper, but when you now go to site, it becomes, in fact, it begins to fail from the first stage. So I advise us that we take note of these things. Some of these things I mentioned are things we already know about, but it's good we always put them into consideration when we want to commence our design. Then here we have depth of beam. This is the fourth setting. When you start your analysis, you can always, when the design fails at this, you have the option. We are going to see that where you can give the software information on what to do. But this is the minimum depth you are recommending as the first setting. And then this is breadth of beam. Normally, some architects prefer to use 225, while some prefer to use 230. So it's always advisable to use what the architect has used. If the architect has used 225, you should also use 225. If the architect has used 230, is also good, because if the architect is using 225 and you are using 230, what happens is that there will be 5 mm less. That's if you're using 225 and you're using for every of your dimension. So it's always good for you to use the same thickness of wall, so that your dimension will be the same thing. So every other thing there, the unit weight of block or wall, depending on the wall you're using, if it is block wall, if it is, all these things are in the code and they have your unit weights. These days, we have different materials. If the materials you are using, every material you use for construction, if you go and check at the manufacturer's information, you will see the information that they are always provided there, so that when you are designing you will always make use of the appropriate information for your design. So when you have finished doing all these things, the next thing you do is to click on apply changes. But for the purpose of this work, I talked about this is a training assumptions. We are going to be assuming our parameters for the purpose of this work. But in real life situation, please always insist that the right things be done. Thank you. Now, what do? We are going to start with a very simple, model, which I will just model for to have a general overview of how the software works. And then we now go to some complex, situations. The first thing I do is you go to a rectangular panel. Over 80% of the work we are going to be doing will be practically on modeling. If you're able to understand the modeling, every other thing is just Jara. The design is just one way. Once you have finished your model, once you want to design, just one click, you get your design, detailing the same thing. But you should be able to understand the modeling. The modeling is very important. If you're able to understand how to model, how to arrange your work, almost everything we see up here is all about modeling. Only a little component of it is about design and preparation of your paper work. So we are going to spend much time, very much time in our modeling than every other thing. And that is the same thing with most softwares. So I go to rectangular panel, I click on it, I pick a point. From any side I click. Now, when I click this point, I have not defined the properties of this panel. I go back here. Once I select this panel, I go back. You can see the panel properties. I can be able to say, by default, what I drew give me 5.5 by, that's height here, means the panel, the slab is, is a horizontal, is a plane. But because we are using a laptop, and when you are looking at the system with the vertical component, just like as if it is the vertical of your laptop, that is what we mean by height here. And the width is the horizontal part of it. So the height is this distance from here to here. So I can change it to maybe 5 meters, to have 5 meters by 5 meters. And assuming this is what I want to do. And another important part of this software is your geometry. Honestly, if you understand your geometry, I bet you there is nothing you cannot do in this software. Once you understand your geometry, I bet you can fly, because that is one other secret of knowing this software, your geometry. It is very fundamentally important. Once you know your geometry, you are good to go. Now, let's go. I come here, I go to reference by panel. Now you can see different options. Once you select the panel, you see different options. You can copy selected panel right, copy left. If I copy left, it will go to the left. If I copy right, I can copy bottom. And you can see another option, copy last panel left and copy right. These are last panels, these last 4. They are different from the first 4. The first 4 is the selected panel. If you did not select any panel and you just go and copy, it will copy the last one. So for this particular one, I want to copy right. Let me copy again. And let me copy again. Sorry. Now, let me take this one, bottom. Let me take this one, bottom. Assuming this is my model, let me go to view and make it. Assuming this is my model, what I have modeled, and I want to design this. I have finished my modeling. I want to design. It's just very simple. I come here and I create my beam, view, beam, and span. Don't worry about the note. What I will do is this. I think after this, I'm recording this. After this lecture, I'm going to share the link to the participants. You can also watch it, and then, but if you have the software, you can follow us with what we are doing. And now, when you see see this, we are seeing beams, just like every other software used. This beam, when you are designing, I'm not designing a building that has a rough foundation. This beam, there will be no beam on the ground floor level. It's just for us to be able to copy, because it's just like when you write a word and you copy that word and you paste. You cannot copy maybe a dog and you paste somewhere, and what you copied will turn to elephant. It is the same dog that you copied that will be pasted. So it's just for us to be able to copy the floors that will come above. So when we come here, you click on copy floor, you click on copy multiple floors. Assuming we are designing 2 suspended floors. If we are designing 2 suspended floors, what you copy is 3. That is the first floor, the second floor, and the roof level. If we are designing 1 suspended floor, you copy 2. That is the first floor and the roof level. Let me say we are doing 1 suspended floor, we copy we add 2. And here, look at what the information is saying. Make the last floor roof level. If the last floor is not going to be roof level, you uncheck here. Because sometimes there are people that may do their work, their last floor, they want to, it may not be the roof level. If you want to slab it, okay, that is just another information that we are going to provide after we have copied. So our last floor is the roof level. After this, we now go to copy. I have copied and I apply changes. Now, look at it now. It is showing me now 3 levels, 3 floors, 1, 2, 3. I will close this and let's go back and see what we have done to be able to, let me change the, now, at this point, what is showing me now, look at this point, it's showing me ground, first, and the next one is roof. This roof level now, it is still showing it as a floor level, but only that the beams are 300. Now, what do I need to do? First of all, I'm at this roof level. I go back, I'm at my modeling, I go to floor property. Under this floor property, I will see what I will see here under floor property. You will see edit current floor, change current floor panel to roof panel, and you can now change the current floor panel to roof panel. If I change it, look at it, it has changed. Now that means that what is remaining at the roof level is just the beams. The slab is gone. Now at the first floor, now at the ground floor. So with this, it's as good as my work is finished. is as good as my work is finished. At this point now, what I just need to do is to go to design. I come to design, and the software initially, this is the process we used to go. You load, you analyze, you design, you go all through these chains of process. Before this particular icon was introduced, that is the automatic design. With the automatic design, you don't need to go through all these processes again. You just come here, you click on automatic design, and the software will bring up this box, dialog box, and you begin to follow the process. Say start automatic design. As you start automatic design, who is the next person that will come in without muting? I will remove the person. Let us always mute. Now, this is a meeting. So you continue. Everything the software will be asking you, analyzing the structure. Would you like to continue? Yes. The next stage, analyzing the beams. Would you want to continue? Yes. Analyzing this. Would you want to continue? Yes. You continue like that. Designing. Now, this is the floor. You set your parameters for the reinforcement for the slab. In case you have a limit you don't want it to exceed, you can set all your information here. It's very simple to understand. Minimum bar diameter, minimum bar spacing for your bottom outer layer, for your bottom second layer, for your top outer layer, for your top distribution bars. So you finish that, you go to beam. Now let us look at the beam. This is very simple. You have three options here. Now it is giving you minimum bar diameter, maximum bar diameter, minimum length, assuming what we are choosing is 10. Minimum length spacing, assuming we are choosing 200, for instance. And then minimum top bar diameter, that is 12. Now you come to the minimum bar numbers. You have minimum number of Y12, 3. It is giving you minimum number of Y16, 10. Assuming we put 6 here, because when you are choosing the minimum number of size, another thing, that is where I say your experience in site comes to play. When you have a cluster of reinforcement, too many clusters of reinforcement, casting, the penetration of the aggregate becomes a problem. So if the aggregates did not penetrate, that means when you remove your formwork, you may likely have a honeycomb. So you should always choose this number of bars for every particular structural element that we are not allow your aggregates to penetrate very well when you are doing your casting. Now, let me explain what happens here. If you set 6 as minimum number of Y16, and for instance, this as minimum number of Y20, that is just assumption. What it means is this. Assuming we set 8 here, what it means is this, that if you are doing a design and the AS required, for instance, that is going to be 8Y, 9Y16, that is going to be 9Y16. But because you have provided that the minimum number of Y16 is 8, automatically the software cannot give you 9Y16 because you have set a limit. The software will use your area of stay required and go to the next size, which is Y20, and we provide the adequate number of reinforcement that met that that area using Y20. I hope you get what I'm saying. For instance, if what you got was supposed to be 9Y16, because you have set that minimum number of Y16 is 8, it cannot go beyond 8. So immediately it hits that minimum, it will jump to the next size of reinforcement and provide with that size. So your AS provided will now be the equivalent area in Y20. Then the same thing applies also in when it is moving from Y20 to Y25. So instead of when you finish your work, you begin to go through after one another. Oh, I think there will be a cluster here. Let me change. You begin to recalculate and go through your books again to know what is the number of still I'm going to provide in this particular area for this particular area using Y20 against the Y16 you used initially for your design. So this is just what this does. And then the next aspect of it is the final one, which is modify depth of beams option. Number one is don't modify depth of beam. Assuming, for instance, what we chose was depth of beam as our default 450. And what we are telling the software is that even if that 450 did not pass, don't modify my depth of beam. Leave my 450 with me. So it's only you that know what we will do with it when what you are designing failed and you didn't want the software to adjust it. Then the next one is modify depth of beam if necessary and make floor beam depth uniform. Now, one of the things you have to put into consideration when you are designing is also very important, cost. Cost is very important. You have to consider cost, put it into consideration when you are doing your design. Now, what this area is saying is that if out of this, maybe you have 20 beams in a particular floor and one beam fails, maybe beam 1 fails, the depth was 450, what you provided, and it failed at 450, you are telling the software, modify the depth of beam. That is, that beam that failed, modify it and make the floor beams uniform. That the 19 that did not fail, you should therefore make every other beam, assuming it changed it from 450 to 600, you should change the other 19 from 450 to 600. Cost-wise, it is not cost-effective. Now, the last option, modify beam depth if necessary, but do so for only the affected beams. So if you look at this, you see that this is cost-effective. This is cost-effective. And this is the one that we are going to be choosing. So after you have made all the changes, you click on apply changes and you simply go to the next one, which is the column sizing. Now the column sizing, you can also size your column. You can see different sizes. Looking at this structure, I do not think I will get any column size that is more than 225 by 225, or at worst case, 225 by 300. This is where I also said initially that experience comes to bear. Now, why I chose that was maybe from experience over the years. I know that I cannot get something that is more than 300 by 225. So, and if you, at the end of the day, even if I don't check this and I do the design, you will see that it may not be more than these two things that I chose. But for the purpose of this, I can choose, I can just leave them so that we can use it to confirm. I can leave the two open. If I leave it open, that means it's open to the software to choose. But most times, why it is good for you to also guide the software is, most of the times, engineers normally fight with architects on site because they believe that we distort the aesthetics of the building. Yes, the architect, we cannot take it away. That's what we came to meet. Is a prime consultant in any building project. And it is the architect that conceptualized the structure. The architect conceptualized the structure. So as a structural engineer, as much as you can, you should be able to stick to that concept, except otherwise. You should not alter the aesthetics of the building. For instance, you know that thickness of a wall is 225, and you are providing a column that is 300 by 300. Why you have option, maybe to provide a column that is 225 by 450, so that the column can flush with the wall. So these are some of the problems that we normally face with the architects. So you should also look at the aesthetics so that everybody is happy, except otherwise, except where is unavoidable. But that is just that. So, but if you leave it open, maybe the software can even choose 300 by 300, where, you know, that's just by the way. So when you are done with that, you can now click yes, and choose the parameters for your column and click OK. Now, you can see, even as I said, it is only giving me the 2 column types. We shall later see the sizes of these 2 columns. Even the 2 columns are 225 by 225. Maybe what changed was just the reinforcement sizes. So my initial, prediction was right. Now I want to continue with the foundation. You have selected pad foundation. This software does 2 foundations, pad and raft. So when you are about to commence your foundation design, it is asking you, it's telling me that I have selected pad foundation. If that is what if I want to use it, I should click yes. If not, if I click no, it will take me to raft. Now, what I now do is to come to this point. Now, minimum base thickness, I can choose 300 as my minimum. Looking at this, it doesn't change the design. If the design, or if it designs and what it gets is 350 or 400, that is what will be. Now, minimum base length and breadth, I normally put it at 1.2. Now, length of interval, by default, what you have here is 100, but I always like to choose 200 as my interval. Now, let me explain what this place means. For instance, if I put 200 as my interval, what it means is that if my base type 1 is 1.2, now the next base size will be, that one will be an interval of 200. That's 1.4 or 1.6 or 1.8. It cannot be 1.3. It can only be 1.3 if my interval is 100. Take note. If my interval is 100, that is when it can be 1.1, sorry, 1.2, 1.3, 1.4, 1.5. It will be changing based on that interval. But if I put 200, that means if base type 1 is 1.2, the next one will be 1.4, the next one will be 1.6. So if you have this interval 200, I bet you will just have like maybe maximum of 3 base types. But when you reduce the intervals, maybe to 50 or 100, you may have up to so many base types. But for this case, because this building is symmetrical, I don't expect us to have more than 3, because it's a mirror of what is happening at the other side. But if it is a building that is not symmetrical, I bet you may, just for a small duplex, you may end up having up to 10 different base types. Now, staircase design. We didn't create any staircase, so I wouldn't, let me close. By the time we do the next one that has staircase, we are going to, finish. I'm going to show you that one, how it is. So, detailing. I don't want to detail. I don't always want to detail until I have seen what I have done. I always prefer to be in charge of the detailing. I don't want the software to be the one to lead me, because if you continue with this process, it will lead you to even the documentation, the printing of the work, the bending moment diagram, everything, and bar bending schedule. I don't always want to get to that point. What I always prefer is for the software, for me to pause here so that I can be able to look at what the software has given to me. So when I look at it, I can be able to make some changes. The first place I normally go when I finish my work is to go to active floor and look at the foundation map. This is what we call the foundation map. The foundation map gives you a general overview of all the foundation, or everything you have done. For instance, assuming that what I have done here is, what the software has given me here is, maybe this is 1.6 by 1.6 at maybe 300. I may decide that I don't want 300, that on my own, for any reason best known to me, that I want to increase it to 350. Instead of going to AutoCAD to start changing the work one after the other, after I have finished, I can just come here, change it, and then match properties. So whatever I detail will now be according to the changes I have done. The same thing, I can also go here and click on column map. When I see the column map, every information on this column map will, every column in the entire structure, this column map will give me every information I need about them. It will tell me, for instance, if a column started from the first floor and did not get to the ground floor level, I should be able to see it from the levels of the column. If a column started from the ground floor and terminated at the first floor without getting to the roof level, I should be able to see. So at this point, I should be able to see, when I look at column type 1, for instance, I'm seeing the load, the moment, the top level, and the bottom level. So every information about the column as it pertains to this particular structure I have designed, I will be able to see all this information at one glance. So this is the importance of, so if there's any adjustment I need to make on this particular column, maybe, for instance, column type 1 is 4Y12 from roof to first floor, and 4Y16 first floor to ground floor. And the column type 2 is giving me 4Y16 from roof to first, and the 4Y12 for, I can decide on my own, but somebody can decide, okay, I want to make it uniform. I want to make all of them 4Y16 or 4Y16 down, just for reasons best known to the designer. Because the designer, most times when we finish a design, you look at the design you have done, you can decide to make some adjustment, maybe for some safety reasons that is best known to you. So these are some of the things you can do them here. And when you are finished doing them, if you go to detailing, whatever you are detailing will now be the final output that will reflect the changes you have made. Now, let us, assuming that everything is okay, that I'm not making any modification, I can go to modeling again. Sorry, I can go to view, I go to floor view, I'm at the ground level, I can go to detailing. Now, if I go to detail, what I can do now, I can go to foundation layout. If I click on foundation layout, look at, let me reduce it like this. You can see the foundation layout. What I have, this is what it looks like. I go to file, and we are going to export to AutoCAD. Now, let me take it to a place where I can easily get it. Day one. I export to AutoCAD. We are going to open AutoCAD for you to see how this looks in AutoCAD. You can also print directly from the software. It is stored here. You can print directly from here. But I want us to look at it from different options available. If you prefer to print from the software direct, you can print. If you prefer to use any other tool to print, you can also equally use. Then we can go to foundation detail, part foundation detail. Now, under part foundation detail, what we are seeing is that we have 3 types of foundation. We have BT1, we have BT2, we have BT3. So what I just need to do is to select one of each of the types. So I don't need to select, because I told you it's symmetrical. I don't need to repeat all these things. If I don't select, if I can select all, there is no need. It will just detail all of them. But I just need, because the software automatically has grouped them according to the foundation types. That's one incredible thing about the software. Once I have done that, you can see the 3 foundation types. It has detailed them. I can just come here and say export to AutoCAD. I will continue. I can also do my column. I have only 2 column types. I will also click OK, and I come here and I export to AutoCAD. I can also go to floor slab detail. You can see my slab. Let me change the scale. This is the slab detailing. You can see how this detailing is. I can also go to File and click on Export to AutoCAD. Come back to detailing. I will go to floor beam detail. This is my beam. Well detailed. I will come back and say Export to AutoCAD. I think that's practically what we are. I don't think there is any other thing okay, I can say floor GA. This is the first floor GA. I can also export to AutoCAD. So all these things I have done, I have exported to AutoCAD. Now I can go to AutoCAD quickly, and I can go to AutoCAD, and the open may be probably one of them. That is opening. Now, this is just, can you see I want to know whether you can see my AutoCAD screen. Can you see my AutoCAD screen?
Yes, it's showing.
Okay, so this is just an example. This is my slab. You can see how the work was presented in AutoCAD. So this is the same way that all of them, if I click on maybe the beam, for instance, you can see the beam in AutoCAD. So this is just how the work will appear in AutoCAD. Let me go back to the okay. I want to go back to the previous window. All right. So this is. Can you see now? Is it the Civilsoft window? So that we'll be on the same page, please. Is this what we are seeing? Is it the Civilsoft page?
Yes.
All right. So we all right. So with this now, the next thing is for you to go to the calculation sheet. We now go to calculation sheet and begin to format the calculation sheet to print the work. So this is just practically how the software works. You can see how simple, assuming it was not for this training, that for instance, I have a work that I'm doing, I can tell you that in a couple of minutes, I will be able to finish the work and finish it in a very good time. So these are just the advantages of using the software. So we are going to go to another example, maybe the one that looks very practical example, and now see how that one is done. Now this one we didn't do any adjustment, because most times you have a work. We are going to do a very simple one to show you how you can create a cantilever beam, how you can create a cantilever slab, and how you can adjust probably a beam when you have a point load. Because in real life situation, you will not have all your columns come out just symmetrical as this one appeared. There are situations where you have to have them in line with what the architect has given to you. You have to navigate through it and then provide solution. Your own is to design. And I bet you, if you give 20 structural engineers one architectural design for them to design, their arrangement may not be the same. But at the end of the day, what all of them are going towards is to have a design that satisfies three things: that is cost effective, that met all the requirements for structural analysis, and then the one that did not distort the aesthetics of the structure. So these are some of the things. But at the end of the day, you see that their arrangement may not be. Mr. A may prefer to place his column here for reasons best known to him. Mr. B may decide to choose this point to place a column. So these are some of the things. At the end of the day, by the time and this software helps you to calculate your volume of concrete, and your area of formwork. These are some of the things that maybe some decisions you take, you can quickly look at, oh, what impact has that decision to do with the materials that will be used for the construction? Maybe you may have a beam spanning 8 meters, and you may have a choice. If that beam, if you add a column, break it into two, that column is not going to cause any obstruction. Now it's a choice for you. Oh, do I have a beam of 8 meters? And if you have a beam of 8 meters, I bet you there is no how you will have reinforcement that is less than probably around 8 or 10 Y20. And just depending on the load it is carrying. And now you begin to look at such as some of the decisions you have to take. What if I break it with a column? The column will reduce the depth of the beam to maybe from 750 or 800 to 450. Reduce the reinforcement. Okay, what of the concrete or the reinforcement of the column, the base of the column? By the time you do one or two analysis, you should be able to know, okay, this decision, this is what is going to save in terms of cost. Because the language the client listens to so easily is the language of saving costs. But I always say, don't let them push you because they want you to save costs to do what is against the ethics of the profession. So we continue. Now, the next one we look at is another work. Let me okay, let's move. I didn't save this work. Before we go to the next one, let me just okay. This was what I was looking for. It was missed. Okay, before we go to the next one, I want to create another work for us to see, a simpler one, for us to see how we can. I want to create a simpler one for us to see how we can, do some adjustment when it comes to point load and the point loads, how to handle point loads, how to handle cantilever beams, cantilever slabs, so that we can now move further in a real life complex situation, and now see how to do that. Seriously, please, I think I saw somebody that I sincerely need to acknowledge his presence. He's a very renowned Nigerian professor. When a professor is following your lecture, you have to pause and have to be very careful of what you say. Engineer Professor Beredugo. Engineer Professor Beredugo is a very senior engineer and who has carved his niche in the engineering practice in Nigeria. You may be surprised to note that he's over 90 years and still very active in the profession. He attended one of my classes in Port Harcourt some years back and still very committed to the cause. You're welcome, sir. So I go straight to the next stage, which is the next example. Now,
Thank you for recognition.
Thank you very much, sir. And I don't know. Okay, thank you very much, sir. Wow, I'm seeing so many senior engineers. At the end of the lecture, I'm going to really, acknowledge their presence. Engineer Chibong, and so many of them I'm seeing that have joined this lecture. I think I'm honored to have them. Their Kogu is also here, many of them. Now, you can see my screen now. Can you see my screen? If you can see it so that we can proceed. I have shared. I don't know whether what I shared is showing.
Yes, we can see it. We
Yes,
can
it's
see it.
showing.
Okay, fantastic. All right, so we continue. Just like I said earlier, if you open the software, what you will see first is this setting, the default setting. I have explained this extensively, how you are going to go about this and what you need to do. When you have done this, you click on apply changes, and then you continue with your work. Now, let me show you what I want to do. Oh, Engineer Gube is also here. Now, I go straight to this point. I pick a panel. This is just almost like what we did before, but I'm going to stagger it now so that we see a different thing altogether. Now, when I have this, I can come and change the properties. My height, assuming my height is 6 meters, for instance, and my width, I can retain the 4.5 meters. Now, I have this. I come back here, pick a different one, and I say bottom. Now, let me reduce the view so that we can see what I'm doing. Now I have this. The other one I did was symmetrical. I want to do something that is not symmetrical. So under modeling, still, I come here and do copyright. Now there's something I want to do. I want to include, in this particular work, I'm going to include cantilever beam and cantilever slab, and we are going to see the difference between the two. Most of the times we mix the two up, and then if you come to site, if you see where a cantilever beam is carrying a slab, most of the times you see people still reinforcing the slab as if it is a slab that is cantilevered. So we are going to use this also to show the difference between the two, and also see how we can navigate through our problems using this method. Now, I come here. I told you when I was starting that the secret of this software is what I call understanding your geometry. Now, if you look at the software is so easy, so simple that it has, if you look at, for instance, if I click on this particular object, if I come to object property, now look at what is showing here. Under object property, I am seeing other information. If you follow this, everything you see on this software has a reason. The developer cannot just come and start giving properties of the object if they don't have any role they play. Now you have panel edge conditions, you have start point X. Now let us look at this. This object I selected, the information here is that the start point on the x-axis is 7.5 meters. That is, this is the x-axis, the horizontal axis. This is the y-axis. That is, it is telling me that this point, from 0 point to the point where this particular panel started on the x-axis is 7.5 meters. And the start point on the y-axis is 2 meters. That is, this is the y-axis, that this is 0. From this point to, from here to here, the offset on the y-axis is 2 meters. Now, why I'm emphasizing on this is that this start point will help us navigate to what we want to do now. Assuming I want to bring this particular object down by 3 meters. Assuming I want to bring it down by 3 meters. What do I do? How do I bring it down? Since I have already known that from here to here is 2 meters, and I want to bring it further to this point, what I need to change is to change my start point, because what I just need to do is to change the start point of this object now on the y, because you first of all ask yourself, is it coming down or is it coming up? Is it moving on the vertical or is it moving on the horizontal axis? Since it is going to move on the vertical axis, now I will ask myself, I already know from here to here as 2 meters. I already know that I am expected to move it down by 3 meters from here to here to be at the middle of this, to start from the middle of this panel 1. So what do I need to do? I will go to the panel properties and I will check the start point. I already know 2. If I add 3 to the 2 for it to come down, it will become 5. That means what I just need to do is to increase my start point on the y-axis to 5 meters. Once I do it, look at what happens. So if you are doing a design and you have staggered panels, no matter how the architect has arranged it, this can do it. It's just for you to understand. It's just for you to understand the properties. Once you understand the properties, understand the start point, understand the end point, I'm telling you, you are going to get it right. Once you get it, once you understand it, you are going to get it right. So now I can come further and say, I want to bring this one bottom, but I want it to just be 3 meters. If I want it to be 3 meters, I just go here and change my height to 3 meters. If I change my height to 3 meters, it comes here. So this is what I have. This is what I have. Now, the software by default, at any point where you have 2 beams intersecting, the software by default assumes that a column will be at that point. If you don't define what will be there, the software will add a column at that point. Now, let's look at let's create our beams. What do I mean? The software, if I do this, if I copy floor now, what I will see is that I will have a column here, 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 I will have a column, I will have, at all these points you have these dots. Those are the points you have intersections. So at every intersection, the software adds a column, but that is not the situation in real life situation. Now, what I want to do is this. I want to have a column here, a column here, a column here. I want to have here. I don't want a column here. I don't want a column here. So on this axis, I just need 3 columns, just like this, to be like this particular one. 1, 2, 3. 1, 2, 3. So at these midpoints, I don't need columns. That's the decision I want to take in my design. Somebody, just as I said earlier, somebody may want to do his design and decides that he wants a column here, a column here, a column. He may have 5 columns. But on this axis, I want to design only 3 columns. So it's a choice I have made. Now, how do I give the software this information? Then I will also have my column here, here, and here. How do I communicate this to the software? You know, as I said earlier, everything about design is garbage in, garbage out. It is the information you give that the software is going to use to give you the output. Now, if you look at this point, I have 1, 2, 3, 4, 4 spans. 1, 2, 3, 4, 4 spans here. So if I am going to have 2 columns, 3 columns, 1, 2, 3, that means what I'm invariably saying is that I want to reduce these 4 spans to 2 spans. That is from here to here, from here to here. Therefore, what it means is that this particular beam here will be resting on this primary beam. That means this will be a secondary beam resting on this primary beam. And that means, in a simple term, that this is a point load. At this point, there'll be a point load. When we finish, we are going to view it. There's what we call sketchpad view. We are going to use sketchpad to view this particular beam. So we will see the loading arrangement and we see even the point load, how it comes, because in the university days, our lecturers, when we did structural analysis, they would just sketch a beam and then they put the distributed loads and they put point loads and they ask you to analyze. You will now analyze using different methods. If you are using the Macaulay's method or the there are many of the options you have to use. You can use, but we have that sketch pad here, and we can, with that sketch pad, you can draw or you can pick any particular problem on any particular textbook. You can draw it here, and when you draw it, you put the same load. You ask the software to analyze, and when it analyzes it, you will see that you virtually get the same answer. Now, this is that's what we do subsequently. But let's look at what we have here. Now, at this point, before we even do what we are going to do, let me show you something. If I click on this particular beam, and if I go to the property of the beam, I want to show you something. I come to type of support. If you look at this point, you see that what it is showing here is that the support is column support. It is showing that it is column support. Why I want you to see it now is
the floor drain.
Why I want you to see it is that we are going to make adjustment.
Water is collected on that.
We are going to make adjustments. By the time we make this adjustment we are about to make, we'll still go back to that particular beam that showed column support. We will see what will be of that column. Now, what do we do? Because we don't want a column here. To eliminate this column, we want to stretch this beam. Let us deal with these two first, because we want to convert these two to one single span. So we can pick any of the two. It's either we can pick one, we can pick the second one. But let me pick the second one. If I pick the second one, once I click on it, I can go to my keyboard and click on delete, or you can right click and also choose delete. Once I click on delete, sorry, I had to pause the person. Once I click on delete, now see, always follow the instructions. Voila, it will be very easy for you if you read the instruction before you take an action. Now, the software says that you are about to delete span 2 from beam 7. You are about to delete span 2 from beam 7. Now, it is giving you actions, options. The first action is this: stretch span 1, or you can stretch.
There's something deeper that happens.
The first action you take is, it's giving you, the first option is stretch span, the span before, that is span 1, or stretch the span after, that is span 3. Now, let us look at these two options. Let us look at what gives us what we want to do. The first option is, we selected this second span. The first option is stretch the span before. You know that the aim is to have a column here and a column here. If we stretch the span before, it will stretch from here. Since we are deleting this one, it will stretch from here to here. That means it becomes a single span here. But if we say stretch the span after, that means it is this span after that we stretch from here to here. Now, let me tell you the implication. If we stretch the span before, automatically this column here will be eliminated. But if we stretch the span after, it is this column that will be eliminated. And from our first decision, we say that we want this column, we want this column, we want this column. So the second option does not give us what we are looking for. So we maintain the first option, which is stretch the span before. So with that, we click on, we have selected the one that pertains to what we want to do. We now look at, if we go back and touch it, you can see that it has stretched. This span has become, initially it was 2 spans, it has become 1 span. Now let us go back and check. You know, initially when I clicked on this particular beam, I came back, I went to the support type, and it was showing column support. Immediately I stretched this particular one. Something has happened to this. Something has happened to this particular beam. The start support, it is showing us now that the start support is now primary beam support. Initially, the start support was column and the end was column. But now, because I have removed this column here, definitely something must support this particular beam. Something must support this particular beam at this point. Something must support the beam at this point. If a column is not supporting it, that means another beam will support it. So it is now showing us that it is primary beam support, which means that this is the primary beam providing support to this secondary beam. That is to say, at this point, we have a point load. Now we go to the next one. Excuse me. The next one, the same thing we did. We want to have from here to here as a single span. So what do? Is that we choose here or we choose here? But let us choose this one so that we can see the options it will give. So if I click on delete, yes, yes. Now see the options. The first option says stretch the span before. The second option says stretch the span after. Now, which one gives us what we want? Remember that we want a column here, we want a column here, we want a column here. Now, if we stretch the one before, that means we are stretching this one from here to here. That is not what we are looking for. If we stretch from here to here, that means we will eliminate this column at the middle. But if we follow the second option, which is stretching from here to here backwards, that means we are going to eliminate this column here. So the second option is actually what gives us what we are looking for. Now we have done that. Let's look at this. We have two spans of that beam now. And now from 4 to 2, let us go and check this to know whether it changed automatically. This one also changed from column support to primary beam support. So this is the simple technique. This is the simple way on how you can adjust your columns. And by the time your beams is always good, the software has a provision where you can, it says insert column, insert this insert, but honestly speaking, from experience, the best way to do it is to adjust your beams. If you adjust your beams, the column will fall in as according to the adjustment you have made. For instance, if I want to insert a column, for instance, if I wanted to insert at this point, because the range from one point to the other is maybe the interval, this is 1.5 to 1.5. I may insert at the wrong point. But if I adjust my beams and define the intersections, the column will always fall in there because the software has been customized to put a column wherever there is an intersection. So with this, now, with this particular arrangement, I can now go and copy. I can copy my multiple floors. I can still change this to 2. I can apply my changes. Now, let's look at this so that we sorry, I'm trying to. So now, this is the first floor. I want to make it 150. And this is the last floor. Now I have not, now you see the arrangement on the first floor. This is that point. I'm telling you, you can see that this particular, there is no column here, there is no column here. That is just what I wanted to show. Now there is something I did mention, which I also want to do. That is on the first floor now. I can come here and I wanted to create a cantilever. And now I can say, let me copyright. I can make assuming I make the width 900. That's for cantilever slab. And assuming I want to have maybe probably a cantilever beam somewhere here. Let's say I put bottom. And let's say I have it at, say, height of 1200 or even 1.5 meters. Now, this one I have not finished. What I want to have here is a cantilever beam. So I have to, first of all, I have to insert my beam. If I want to do a cantilever beam, I have to insert my beam. Sorry, I'm picking the wrong point. You see the problem with inserting. And let me recreate. Now, see what I am doing here. I have just created beams, but I bet you the software sees this beam as that there is a column here. Now let us prove that. If I click on this particular beam now, let me click on this beam. If I go to end support, you can see, and the support type, it is showing me column support. Now, since I want this place to be a cantilever, what do I need to do? It's simple. I come here and change my end support. Now, somebody will ask, what is my start and what is my end support? If you are dealing with a beam that is on the horizontal axis, your start is the one that is closer to 0. That is for your left. The end is the one on your right. If you are dealing with a vertical, if you are dealing with vertical one, the one, for instance, this particular one, this is 0. The start is the one that is closer to the 0, and the end is the one that is the other end of it. So my end here is this point, and that is the point that I have my cantilever. I can change my end support to none. You can see options, primary beam support, none. I change to none. I can come here also and change my end support to none. But there is something that is remaining. Remember that a column is existing here, a column is existing here. And I have dealt with this particular one, I have dealt with this particular one. What of this? If I click for this particular one, it will still be showing column support because we have not dealt with this particular one. If we say this is going to be a cantilever, this is going to be a cantilever, which means that this particular beam will be supported by those cantilevers. So the support of this particular beam will be, for the beam will be primary, because this beam is being supported by two beams. It's being supported here by a beam, it's being supported here by a beam. So that is what we are changing. So in this particular case, we've been able to establish this is a cantilever beam, this is a cantilever beam, but this slab here is not a cantilever slab because it has support here, it has support here, it has support here. All over it, it has support. So it is not. But look at the slab that is a cantilever slab. We are going to show it now, prove it. When we click on this particular slab, because we have not given instruction to the software, the software is still recognizing it as panel type is either two-way or one-way slab. That is what the software is recognizing it as. Now, let us go further to see, to extract another information. Now, basic span effective ratio of this particular panel is showing us 20. That is continuous. Now, let us go back now and go to 2 and take an action. Let us go to 2. If you go to 2 and take an action, the tool now, under the tool, we have this particular icon that says detect cantilever slab. Detect cantilever slab. Once we click on it, it will detect the cantilever slab and will automatically change the parameters once it has detected it. Now, initially, note that the basic span effective ratio was 20, and the information it was giving about this was that it's either a two-way or one-way cantilever, a one-way slab. Now, let's go back. You can see that the panel type has changed automatically. It has changed to cantilever slab. And let us now go and check the basic span effective ratio of that particular. Look at it now. It has changed from 20 to 7. That means the software has detected it as a cantilever slab. So we proceed. Now we go to the roof level. At the roof level now, you know, the cantilever slab may not appear at the roof level, but the beam, we can still have the beam cantilevered at the roof level if, depending on what is happening there, if it's a choice, or we may simply leave it like this. We go to modeling just because of time. Floor property, we change this one to. Now, this is what we have. If we want to view this, we have not. Okay, let us, so that we can view in this sketch pad. Let us quickly do a very fast design of this. As I said earlier, we just start with automatic design and we just take it through. We stop at detailing so that we can be able to I will do this 2 meters. I'll do this 200. I'll give this 300. I can. So detailing, I can say no. Now, under view, I have finished my work, under view. Now, look at what I want us to see. Now, under view, if you look at this particular cantilever, you can see it. You can see that it has beam. Look at the cantilever. Look at the other cantilever, the cantilever slab. You can see only the slab cantilever. This is just a kind of 3D view of it. If I go to my column view, map view, just as I showed you, I can see at a glance the column. I can look at the column map, look at this. Under this, let me see floor view quickly. I can even do my detailing quickly. Let me see. floor beam detail. This is my floor beam detail. You can see it. You can see the cantilever beam. You can see the other cantilever beam, and this is just how it will appear here. Sorry. Oh dear. I think I minimized it too. Sorry, is the screen still showing? Okay. This is how it will show. Now, a very important thing. Let me quickly go to properties, beam. Let me go to modeling. Floor view. Sorry, I'm trying to do this one thing. Okay, yeah, what I'm looking for, I've seen it. Now, under floor view, what I wanted to show you is the properties. Now, under modeling, I can quickly go to beam properties. If I go to beam properties, that particular beam that has cantilever, this is 1, 2, 3, 4, 5, 6, 7, 8, 9. I think beam 9. So 1, 2, 3, 4, 5, 6, 7, 8, beam 8. If I go to beam 8, if I go to beam 8 and click on view in Sketchpad, look at it. You can look at that beam 8. Now, this is the loading arrangement. These are different loads. You can see that point load. Look at this middle. This is a point load. You can see that point load coming from that beam that the two cantilevers we are carrying. You can see, look at these loads, the combination of these loads are this is the middle beam. You have load from one panel, from the left and the right panel, and you have the wall load. Then all of them are these combinations you see here for this particular span, and then you have the point load. And that is how it goes. At a glance, you can see the loading conditions. From the load conditions, you see the bending, the shear force diagrams, the bending moment diagrams, and it runs like that, and you see your final analysis. This is the essence of the Sketchpad. That is what the Sketchpad does. I can even on my own, I can create a new page of Sketchpad and I say sketch a beam.
Why do you like that?
Those I don't know. I don't just like them.
Right. If you don't get bending moment diagram, you know know the deflection right now.
I know. You can create them
Let
small.
me get this. Now I have sketched. This is where I said earlier that you can on your own. You can on your own. You can on your own sketch. For instance, I have sketched this beam. I can pick from here and sketch again. I can pick from here, maybe, and sketch. Now I have sketched this beam. You can pick any particular problem in any particular textbook, just like what I said earlier, our lecturers will give us in our school days. You can sketch the distributed load. If you put it like this, you apply the load. You sketch again. Assuming this is 10, and you sketch again. Assuming this is 20. Now, assuming I want to make the last one a cantilever, this particular one a cantilever, I can just click here and come to the end support. End support, I change it to none. Once I change it to none, it will automatically become a cantilever. Now I can put a point load, sketch point load. I can put my point load here, and it will apply. I can put my point load at this point and add the load. Sorry, let me delete this. I can put my point load, and I can put my point load here. Sorry, I shifted my hand. Even here. Now, if this is the final sketch I have done, it's just very simple. You can just use this particular tool just for check, a quick check on an analysis. Maybe you are in an office and you give a young engineer an assignment to do, and you just want to look at what he has done. You can just sketch with the sketch pad, and the ones you are done with this, it's just one click. You can just say analyze and design the beam. Once you click on it, you scroll, it will look at the distribution tables. It will analyze it, look at the bending and shear force, bending moment and shear force diagram. So this is what it will do, and it will give you the final result of the analysis. So this is what the sketch pad does. So let's go back to our work floor view. So this is where we are. So if we have done with this, the next thing we do is to detail, which we have done. I have done some the beam detail, just the same way we detailed our work. The final thing you have to do is for you to go to prepare and print, which is how to get your calculation sheet. There are two ways you can get your calculation sheet here, or even three ways. You can export your calculation sheet even as DXF file. You can get it in AutoCAD. You can format your calculation sheet in PDF, and you can get it. Then you can have an unformatted calculation sheet in text file, and you can copy and paste in Microsoft Word. Normally, it depends on which one that applies to what we are doing. Now, for instance, if I want to prepare the calculation sheet, Now, once I click here, the box comes out. Now, this box gives you information on what you have to do. Now you have options. Prepare full detailed calculation sheet. Prepare summary calculation sheet. Include bending moment diagram. Include. So if you need any information you need in your calculation, if what you want is the full calculation sheet, if what you want is the summarized one, if you don't want to include the bending moment diagrams, if you want, depending in all these things, the volume, or if you have the detailed one, that means the volume of the calculation sheet will be much. So you will decide on what you want, and also depending on what the approving authority expects you to provide in your submission. Now, you can also come and select the columns. Like for instance, we have here column types. You select the column types that are, if there are 2 column types, even if there are 20 columns, but there are only 2 column types, you select only 2, so that it will give you the analysis of those 2 types. If it is foundation, you select, like you have 3 foundation types. What you just need to do is select 1, you select 2, you select 3, you say, okay, those 3, it doesn't need to repeat. If B type, foundation type 1 is 20, if you select 1, it will just show you the analysis of that one. If you don't select, it will show you all of them. So these are just the secret. When you are done with this next thing you just do is to prepare this. And when you do this, you can, this is the calculation sheet. You can export this to your PDF, and then you print. They are all there from A to Z. Then another, wait, I think I have, another thing you have to do is the second option of calculation sheet, which is prepare unformatted calculation sheet. If I click on prepare unformatted calculation sheet, what it does is this particular one can only be applicable to text file. I can come and select the panel. I have 4 panels. I select all of them. Click OK. I have beams. I select my beams, except if there are ones that are symmetric, I can pick one of it and then name them to be 1. Then you have your column. If I have column type 1, type 2, 3, 4, I won't have. So this is where I say it is important for you to look at the work before you print, so that you can be able to do some adjustment. For foundation, I have. So this is what you do, and you now say generate calculation sheet. You can see it will generate basically the summary of the calculation sheet. You can now say save. If I click on save, it will save it as a text file, which I can open in Microsoft Word and then copy to any document, assuming I have my template where I want to print my calculation sheet from. You will just do that. So this is just basically what the software is all about. And I bet you in a very short time, you can be able, if I have, for instance, a duplex, I can do that duplex, finish and print my work in less than an hour. So this is what the just as I said when I was starting, it's not about the knowledge of the software. It's about knowing it from the first principle. If you know it from the first principle, I bet you there is no limit to what you can do with any software. So I think we have to stop here to take questions, and then if there is need for us to continue, it's already 5:13. We take the next question up to 5:30, and then we call it a day. Then if there are further questions or further inquiries, maybe we can do that offline as time permits. So I take questions so we can proceed.
Engineer Ben,
If you want
thank you very much for the lecture.
Okay.
My question is just this. I'm Engineer Bewaji.
Okay.
My question is this. I designed a 3-floor design and had water tank, which I specified. But while printing, the thing didn't bring out the water slab design. I had to change it by increasing creating another floor where that slab is before I could print the details of that slab. Why was that? Why did that happen?
I didn't get you quite well. Please, can you come again?
Well, the issue is this. I had a 3-floor design, and at the roof level, I had a water tank slab there, which I specified. And when I had to print, it didn't print the details of that water tank slab. So I had to go and create another floor around the water tank slab alone. It was after that it now printed the water tank slab. Why did that happen?
No, it has to. Now let me tell you. Maybe it may be from the information you gave the software. You know, at the beginning.
Yes.
When we say you go to the floor property, when we want to change the floor panel to roof panel.
Roof panel, yes.
We will. Let me show you what I am trying to say. Now, if you look at this point, what is showing here is the roof panel.
Yes.
Now, assuming I come here and click this particular
panel. Yes.
And I
change it to.
I go to change the panel property.
Yes.
And I change the panel property to be a floor panel.
Yes.
These particular ones that are void.
Yes.
Will remain void.
Yeah.
It's just like when you create a void in your staircase.
Yes.
It will remain void. But the other ones that are solid will come as solid. So you need to change the particular. If you had created all of them to be void, it will not. So you have to, that particular one where you want to have your water tank.
Yes.
You have to give the software instruction. This one,
which I did.
Maybe you didn't. What will happen is this. Maybe after this lecture, you can send me the kind of the model. I will look at the way you did it before. I will run through it and then tell you where the mistake came from. But if you follow the instruction, if you like this each particular panel has its own property.
Yes, I know.
If you want to give them a general property, then we follow it. So if you want to tackle one individual panel, you have to take that panel and give the instruction to the software pertaining to that particular panel, and it will pick that information.
Okay.
All right. Thank you. Engineer
Okay, maybe later in the evening I'll call you.
Okay, sir.
Thank you. All right. Thank you very much, sir.
Engineer Berodugo. You can go on, sir. Engineer Berodugo, you can go on, sir.
He needs to unmute himself.
Yes, I have asked him to unmute. Engineer Berodugo, you can go on. Okay, let's take Engineer Obumudia.
Yeah, good evening, sir.
Okay.
Yeah, name is Obumudia. I only have one question, though you have broken it down severally, so many of the gray areas. My only concern is this: what about when you're dealing with curved beam?
Yeah, we have
the curved beam and the curved slab.
What we have here in the software is we have, you know, the beams fall around the slab. If you go here, you will see that we have special panels. Special panels, we have something like, if you have triangular panels, look at it here.
Yeah.
You have these ones, assuming I have, this one is the one you can draw according to what the architect has put. Then you can have these. These ones are for chamfered panels, but you have to, when you draw it, it comes as rectangular, but the properties are different from the properties of the normal panel. Then you can come here and see bottom. These are additional information. You can see here bottom left radius, bottom left type. Then you have top. We are dealing with the right because that is where I want to where it's showing top right. Is it rounded? Is it chamfered? If it is chamfered, for instance, I put chamfered. Now it will ask me what is the let me get a top. I'm dealing with the top right. So the top right now, assuming I say 2 meters, you can see it.
Okay.
Now, if it is rounded, if I chose rounded, maybe bottom, if bottom is rounded, if I choose rounded, it will go, it will ask me for the radius. It will ask me for the radius, and I will choose the radius for that particular edge, and you will see the curve. So it does that.
Okay. So we can only round the entire outer part then.
Yeah.
If we choose to.
If you choose to, you choose the. It depends. All depends on the radius.
So what about the beam? The beam can equally follow too.
Of course, when you form the slab, The next thing is the beam.
The beam.
But except
okay.
the slab is a cantilever.
Okay.
Yeah.
Oh, thanks a lot. I appreciate.
All right. Okay. Any other question? Okay, Engineer Beredugo is still asking. Sir, you can reduce.
I have unmuted myself.
Okay, you can go on, sir.
Thank you very much for a very instructive presentation. But may I just find out if the software can handle dynamic loads, and in this particular case, wind loads for structures above 3 floors, particularly?
Yes, you know, like it has capacity to do that, but there are technicalities for doing that, which we didn't handle. And it's also the higher, you know, it has different editions: the professional, the ultimate, and the enterprise, and the standard. Those ones are the ones that, but it has, so the application is there, how you apply the wind load. And the, you know, the software also does steel design, but what it does is the steel roof truss design, different trusses, but it doesn't take the stanchions. When you pick the loads from the and there's no way you can design roof truss without putting into consideration the wind load. So it's there, and is the application. Maybe any lecture, the next lecture we are going to do, we are going to touch that area, maybe to some high rise, to see how that is applied. But we cannot, in this context, because of time, we may not be able to go to the nitty-gritty of the whole software. It's just to give a general overview of what it does or what it has capacity to do. All right.
Thank you for the explanation.
All right. Thank you very much, sir. Engineer Ojie.
Yes, good evening, everyone. Thank you very much, sir, for this wonderful presentation. Yeah, I'm Engineer Ojile. Can you hear me?
I can hear you clearly.
Okay. So what I'm in my own question, if can one do design on AutoCAD, like you do your GA on AutoCAD and import it to this environment for your design?
Now, it is possible. It's just like importing from AutoCAD, just like other software. But the truth is this: you know, you have to reduce or remove all the walls and make it to
DXF file
to be able to do that. It is the same procedure. It is done here. But personally, me, I find it easier for me to do my modeling. I have tried the two options, and the one I find very convenient is for me to do my modeling. And once I finish my modeling, I find it easier to do my modeling. Instead of going through, I don't think there is anything an architect will model that I will not be able to find my way how to navigate around it using the software. So I've used it for years, and I have been able to do even the most of the complex structures you can think of, and I was able to navigate my way through it. So that is a choice. If you feel, I know the problem is normally when you have curves and some complex structures, you just want to import, and yeah, so it is doable, very, very doable. The same method, once you change to DSF files, you can be able to import. It is there. It is there. Look at it. Import. Look at it here. Import drawing DSF file.
Okay.
Yeah.
Okay.
It is there.
Okay. Then final question. This I think this is 9.0.
Yes.
This 9.0, how many panels can it design? Because during my university days, I was following it up very well. I think I used up to I think 8.0 or so. So till today, they used to send me messages. It's like the cost then, I don't know the current cost of those packages now, because I know things are changing. Then how many panels can this one design?
Okay, the software comes in 4 editions, 5 editions. We have the basic, which is the student edition, 7 panels. We have the standard, which is 20 panels per floor. We have the enterprise, which is 40 panels per floor. We have the professional, which is 60 panels per floor. And we have the ultimate, which is unlimited. Then they have their different cost. The discounted rate, what we normally give, is all depending on the promo that is going on at a particular point in time. You know, the software has moved from Nigeria to the United Kingdom. And now what happens is that the producer of the software, the owner of the software, stays in United Kingdom, and he has a fixed, the software was matched against dollar and pounds. So at a particular time, it was a particular, it was used, dollar was used to rate it. But now you know what dollar is in the market at a point now. In fact, if you have to use the prevailing price of dollar or pounds in the market, it will be a very big problem. But for the last trainings we have done on discounted rate, what we normally do is for standard edition, we have done trainings for standard edition at 150, we have done at 100. We have given the software at 100, discounted rate, 100,000 naira. We have given at 1, depending on the that's why I say depending on the promo that is available. Like Easter is coming, we may have Easter promo. We can give 40% discount. We can give 30% discount. We normally have such situations. But if we have to go by the prevailing rate, standard edition now should be costing up to 200,000 naira. But when we have the windows of that promo, if you key into them, I think you will get them at an affordable price.
Okay.
Engineer Okolo Valentine.
Yes, and everyone present in the class. Actually, I'm not an engineer, so to say. I'm a student, so but I'm happy to be here. I'm happy to be here.
Student, what are you studying?
Civil engineering, sir. Civil engineering.
Which university?
Enugu State University of Science and Technology, sir.
Oh, that's interesting. What level?
Yes, sir. 200 level currently, sir.
Wow. So how did you know about the program?
Yeah, one of my uncle, he's based in Abuja. Yeah, he finished in the same suit. So he's an electrical engineer. So he was the one that sent me the link.
Wow.
He said I should look into it. So I was very happy when he sent me such link, because not every day that such things come across. You understand? And nobody gives this kind of.
That's interesting.
Nobody gives this kind of opportunity free these days. So I was happy. Actually, I was even here by 2:58. Yes.
Okay.
So I wanted to ask, because I noticed that everybody here was a senior engineer. No one was in my level. So I wanted to ask if there were classes.
You will get there.
Yeah, eventually, sir. Eventually. So I wonder if there are classes for people in my level, or is it only for the big guys?
Nobody's a big guy here. All of us are, when it comes to an engineering profession, that is why it's a very unique profession. All of us, we don't see anybody as a big guy. All of us are equal. What we do is to provide solutions to the society, and the solution can come from anybody. So we are all equal. And why I was particular, when you mentioned this suite, I smiled, because that was the school I graduated from. And And ESUT is one of the first beneficiaries of this software, because one of the lecturers that reviewed the software that drove it, Engineer Meko Job, also is from ESUT. We have other senior engineers and other professors from UNN, Professor Sadebe, and many of them, a host of other professors and senior structural engineers from other institutions that made input in the software. And we have done a lot of trainings, even free trainings for ESU students. Many, you were not in the school then, many years ago. We have also done for University of Nigeria and Nsukka at a point adopted this for their, as part of their course for, what's it called? Use of computer applications. I know I was the person that went to UNN to teach them some years back. So we are always available. In fact, I will discuss with your HOD, who is in close contact with me, Engineer Ike.
Yes,
I will see if there will be an opportunity anytime I'm coming to Enugu. I wouldn't mind. I can arrange for a free on-site contact class for ESUT. That's my alma mater. I have been contributing to ESUT development, sending materials when Ojogo was HOD to support the students then. So I will continue to do that. Since you have made that request, you will tell that your uncle to send you my number, so you can keep in touch with me. At any time, we can keep in touch. Anytime I'm coming to Enugu, I'm going to inform you, and I assure you I will organize one day course for the students in ESUT for free.
Okay, sir.
All right. The next person, please, so that we can wrap up.
Thank you, sir.
The final person, so we can wrap up. Okay, I think if there is no other question, Valentine Okolo is raising his hand. If there is no other question, I want to appreciate, sincerely thank all our very senior engineers who have joined us. So I've left. I can still see the engineer Joshua Egube, the executive secretary designate of the Nigerian Society of Engineers. Engineer Beredugo joined us. I saw Engineer Bewaji joined, and I can see Sheriff Shitu, and so many. I saw Engineer Akogu before, and so many other senior engineer Neke. I can even see my classmate, Engineer Obrogo Cruz. Fantastic. Wow. Cruz, you're welcome. Lawale Fawale, and a host of many senior engineers that have joined us today. And this discussion continues. I keep saying that nobody is a monopoly of knowledge in engineering. It's all about, engineering is all about teamwork, coming together to provide solutions to the world. It's only when we are in secondary schools that we covered our books when we are taking exams. But when we go to the university, in engineering classes, we are taught that engineering is a discipline, is a profession. You don't cover your books. You exchange knowledge with others. You learn from them, and they also learn from you. We will continue to hold classes like this at every available opportunity for us to also have cross-pollination of ideas and improve on our knowledge. I think that is all we are going to have for today. I want to sincerely thank all of us for joining this class for today. And we appreciate your time. It's not easy for, in as much as it's free, but it's not easy for, it's not every free lunch you offer to somebody that the person takes. But this free one was offered and you took it. So I want to sincerely appreciate all of you for creating our time to attend. At any particular time you need to discuss further with me, my number is there. I'm typing it now. I've typed my number. You can always call me at any time, contact me. We can discuss further on that. Thank you very much. And I want to use this opportunity also tomorrow for all of us who have joined. I think I have to send the link. Tomorrow is a very special occasion. We have a very senior engineer, a program we run, we call it Inside the Arena. We have a very senior engineer who has made his mark, not just in engineering profession, in structural engineering. He has a first class in structural engineering and from Imperial College, London. I'll send the link for tomorrow's meeting. We call it Inside the Arena. It's an interview section and it is free. And tomorrow, we have already received the gift for tomorrow's program. It will start by 3. Somebody will go home with a printer, a Samsung Galaxy phone, and a package from the company, from his company, Amana Consortium. So one person will win all these prizes for free. So if you want to be the winner, join us tomorrow Inside the Arena as we have this interview session with our very distinguished engineer, Dr. Edith James Amana. I remain yours sincerely, Engineer Ben O.C. Oko. I wish you a very wonderful evening. Thank you once again, and may God bless all of you.
Thank you very much.
Thank you very much, sir.
Grateful. Thank you.
Thank you.